Welcome back guys. Today I'm gonna start working on a new sensor that is TMP101NA, that's a temperature sensor. Regarding the recent videos we have showed, we have been working on different digital temperature sensors. So let's add a new one to that series. And to know more about this sensor, let's have a look over the website that is controleverything.com and here search on for this sensor that is TMP101NA. Now we see that it's a digital temperature sensor with alert function and it's a I2C temperature sensor 9 to 12 with user selectable resolution, and as you can see the accuracy is there. So some of its features you note it down. Now you can purchase this sensor from here also. I will be working on the interfacing regarding the sensor TMP101 temperature sensor and a Raspberry Pi with a Java code. To get the Java code, let's have a look over the resource tab, and here comes the Java code sample. Now you can download the Java code sample from here. The link is here as zip file. Also you can have the code from github.com and the repository there is control everything community. Now let me show you the hardware we require along with the sensor so that we can have a proper environment regarding the interfacing along with the code of the sensor. This here is our sensor, that is temperature sensor TMP101NA, and these are the GPIO pins of a Raspberry Pi, and as you can see it's a Raspberry Pi. Now what we require is to make a connection among the Raspberry Pi and the GPIO pins and with the sensor. So what do we need is an I2C shield, which you are able to see on my screen, and it's available on the website controleverything.com. Now gently place over the I2C shield over the GPIO pins of the Raspberry Pi, which comes into the picture right now, and we want to make a connection with the sensor also. So we need a connecting cable. Now make this connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this set of rule for the I2C shield. Now we need to power up our Raspberry Pi, and we need a micro USB cable just like this, and gently put it over the power jack. Finally we need an internet connection so that we can set up our Raspberry Pi along with the sensor. So there are two ways. First of all, an Ethernet cable can be connected at the Ethernet jack and you can insert it up there. Now if you have an wireless adapter, nano adapter, you can also use that. It might save your day also. So finally we are done with the connections part. What do we require is to a code so that we can interface it with our sensor. Let's have a look over that also. Let's have a look over the Java code so that we can interface this with a Raspberry Pi and our sensor TMP101NA. So for that we have to visit the website that is github.com, and here we have to search for the repository that is control everything community. Now get over it, and here this is the required sensor and this is the Java code we are talking about. Let's have a look over the instructions we need to follow to pursue this code, which says that we have to download and install Pi4j library on the Raspberry Pi, and the steps are here. It's pi4j.com, and you can see yourself how we can install the library. As you can see the demands, the conditions, dependencies, all are there. Please note it down carefully. Now this is the command to compile the Java code, and this is to run the Java code. Please note it down and get back to the Java code so that we can explore it. As you can see, it's a .java extension file. The first thing you notice in the code that we have imported some of the libraries so that we can use some of the functionalities later in this code. And we have created a public class named TMP101NA. We have the address of the sensor, that is bus.getDevice, and it's 0x49 as you can see. Coming to the writing section part, we have selected configuration register having address 0x01, and the command we have sent is to continuous conversion comparator mode 12-bit resolution, and it's 0x60. The writing command is here. Now we want to read data back from the address that is 0x00, and we are reading 2 bytes of data for the temperature. Now as we are done with the data, now we want to convert the data according to the formulas we have been in the data sheet, right? We have seen in. Now what we're gonna do is to have some values calculated, and we want to display the result on the screen, and the best way is to print out, as you can see, temperature in Celsius and Fahrenheit scales, and you can see it's a perfectly formatted in 2 places of floating volume. C and F scale are there. Now it's a very simple and generalized code, as you can see. Now what we're gonna do is to show the working. Let's see it. Now comes the interesting part where we have to show the working, and let's copy this entire Java code. Now open up the terminal regarding the Raspberry Pi, connect it through internet. Here create a new file TMP101NA.java extension, as you can see, and here we go. Paste the entire code here, save it, and this is the command to compile the code, as you can see on my screen. And here we go, it's done. Now this is the command to run the code, as we have noted down earlier. Now as you can see, temperature in Celsius and Fahrenheit are there. Now again running, there is a very minute change, but when I exhale over the sensor, there might be some changes. Please note it down. There you can see the temperature increases. As I continue exhale, the temperature will change. So this is how the Java code works with this particular sensor alongside Raspberry Pi. Now what we're gonna do is to have a look over the benefits, the applications regarding the sensor, and please note it down. The TMP101NA device is a digital temperature sensor ideal for negative temperature coefficient and positive temperature coefficient thermistor replacement. The device offers a typical accuracy of ±1 degree Celsius without requiring calibration or external component signal conditioning. The TMP101 device features SMBus Two-Wire and I2C interface compatibility. The device allows up to 8 devices on one bus. The TMP101 device offers an SMBus alert function with up to 3 devices per bus. Now, this device is ideal for a lot of applications like power supply temperature monitoring, computer peripheral thermal protection, cell phones, battery management, thermostat controls, environmental monitoring and HVAC, and a lot more. This sensor is available and can be purchased from the website controleverything.com, and you can get the code from resource tab. After that, you can download it from there also. Also, you can get the code from GitHub repository, that is Control Everything Community. In the end, I would just like to make it clear that at any point, if you are not able to understand any part regarding any section of this video, you can have your further queries on controleverything.com, and you can post your comments on the community page. For blogs, articles which are relevant to this video, you can have a look over instructables.com and search us for them. Also, to subscribe more video tutorials which are just like this, you can go to our YouTube channel. Now, in the end, I hope you enjoyed this video and have a good one of yourself. Thanks a lot for watching.